Hi there once again and welcome to another Expresso mechanic tutorial, and in this one we're going to be looking at making dice. In order to do this we're going to use a combination of Expresso, Python and Dynamics, and we're also going to be introducing the polygon node, which is something I've never used in a tutorial before. Anyway, without further ado, let's see if we can make this happen. Because there's very little going on here and it's very simple to achieve, I'm not going to bother building this one from scratch. We'll just have a quick look at what I've done. For the table part of it, I've just got a surround and a base. They're both extrudes, as you can see. If we switch those off just briefly. Now if we look at the spline for the surround, it started life as an arc. I made it editable. I added a couple of points and dragged these down to the bottom here of the table at the correct position, or whatever I deemed to be the correct position, and then all I did, I came up to spline, clone, create outline, and then simply drop that into the surround there, and that created that part of it. The base, similar story. Again, it started out as an arc, added a couple of points, and then simply closed the spline, dropped it into the base and extruded that by just 1 centimeter. The surround I extruded by 600. And that's it. That's the table done. The dice, just a couple of cubes that have been made editable. I made them editable for the simple reason that we are going to be using the polygon node, and that only works with geometric objects. So you've got to make your objects editable. And then with regard to the texture for the dice, this is the most complex part for me because I don't use body paint a great deal, and I created that in there. So there was a little bit of head scratching, a little bit of learning curve for me there with actually making that happen. But I got there in the end, and I got my dice texture done. And then finally, just to finish it off, a couple of text splines thrown into a couple of extrudes just to tell us what we've rolled and when the dice arrive at their final destinations. And that's it. It's that simple. Our first port of call in order to make this all work is to get a null, and we're going to rename it Expresso. We'll give it an Expresso tag, so come down to Program Expresso, and we're there. I can then drag in dice number 1 as my first object and give that an object port for now. Moving on from here, we now get our now legendary polygon node. And we can plug our dice's object output into the object input of the polygon node there, and straight away we get rid of that yellow top. Now the polygon node is actually very similar to the point node in the way that it works. It's effectively, well, it's a point node for polygons, you could almost say. So you've got a polygon index over here at the input stage, and at the output stage we've simply got a polygon count at the moment, which we don't need to worry about. What we do need to worry about is the polygon normal, because it's the polygon normals that we're actually interested in, the normal direction of our polygons. So we're already in polygon mode here. If I just select this dice, now straight away we've got this polygon facing upwards, and in the structure manager here we can see that we have an index value of 4. That's the polygon that would give us our score, because it's facing in the positive Y. That's effectively what we're doing here. We want to know which polygon, and of course we've got 6 possibilities with a cube. We want to know which of those 6 polygons is facing upwards when the dice come to their final resting place. And whatever's printed on that particular face is going to be the score that's going to end up here. That's what we're looking to achieve. So how do we do this? Well, with the polygon normal output here, if I just hold down my control key on my Mac and I say port information, let's just see what we're getting here. So the type is a vector. Now that's very useful to us. So if we get an adapter node here and we come down to vector Turials, we can plug the output into the input there, and now we're looking at what these are doing. And what we're interested in, of course, is the actual Y output here, because obviously this particular polygon is facing upwards, so it's facing in the positive Y direction, and that's what we're interested in. So if we get a result node, we can plug that into the Y there, Now at the moment we're getting nothing in there because we're currently looking at polygon 0. We don't want to do that. We want to look at polygon number 4. So let's come across to our attributes here, and in the index value here, let's just put a 4 in there. And straight away we get a 1 at the result. So that's the all-important number. And number 1 at the Y output here. If we're getting a number 1, whatever the corresponding polygon, that's the face that we're interested in, and that's the face that's going to tell us what the score is. Moving on from here, the first thing I'm going to add is an iteration node. Bring that one in there, and I'm going to plumb that into the polygon index because we need to sequence through all 6 faces of our dice in order to check which one is the one that we're interested in. So with the iteration start, we'll leave that at 0 and we'll put the end as 5, allowing us 6 iterations. Moving on from here, the next thing we need to do is bring in a Python node. Nothing particularly complex going in this particular one, but the thing I do need to do is just set it up. So I'm going to remove all the ports for now and then just put some new ones in and start from scratch. So I need 2 integers at the input stage and I need a single integer at the output stage. So that's those 2, and we'll rename them. The first one I'm going to rename, I'm just going to simply call it I for iteration, and that's going to be plumbed in, or the iteration is going to be plumbed into that particular port. And this one I'm going to rename upside. And then finally at the output I'm just going to name this one number. So that's our ports all set up. Now for the upside, I'm just going to plug in the Y from the vector Turials in there. And what I'll do, I'll just change those around so it's a little bit tidier. And I can lose the result now, I don't need that anymore. Okay, great. So in my Python node, I'm just going to open the editor just to make it a little bit easier to see what we're doing. Global number is absolutely fine. That's just the output there. That would be put there automatically. We can just get rid of this. Don't need that. And we're going to start with a list of numbers. So I'm going to say nums is equal to, open brackets, and we'll just say 4, 2, 3, 5, 1, 6. So these are a representation of each of the numbers on the various faces. Now they are in a strange sequence, but that's because they don't actually correspond. Wait, 1 does not correspond to 0, say, as an index. We know that it corresponds to 4. Hence why, if we start with 0, 1, 2, 3, and 4, we find that 1 is at index value 4, and every other index, so 4 here actually corresponds to 0 in the iteration. That is polygon index 0, the 4, and so on and so forth. And I've obviously worked those out by looking at the structure manager, selecting them individually, and then making a note of the index values and what numbers they actually correspond to on the faces. That's how I've done that. Perfectly simple. So now all I need to do is a couple more lines. So I can simply say if upside is equal to, or greater than actually, or equal to, and I'm going to say 0.99, then number is equal to nums, brackets I. And that's as much as I need to say in there. So what I'm saying here is if my upside is pointing or is greater than 99.99, so in other words, if we're going to get a 1 at this output, then we know that that face is pointing upwards, because obviously these are going to be dynamic cubes, so they're going to rock around and you know, they might not be quite absolutely perfectly aligned with the y-axis. But if the upside is greater than 0.99, then it's going to be correct. That's fine. I mean, it could be 0.999 and that would still be correct. It would still be enough that that would be facing in the upward direction. So that's why I've allowed that little bit of leeway in there. Okay, and that really is all there is to this first little Python section. There's nothing more to it than that. It's just simply a case of scanning through the index values of the polygons, placing this in here, and whichever polygon index corresponds with whatever number happens to be on the upside value there, happens to correspond with the upside, then that's the number that we're going to output at the output port here, and that will go to our score. I'm just going to execute that to make sure I don't lose anything when I close this down, and that's good. The next step for me is to create some dynamics, well, all the dynamics actually. First of all, we'll get the surround selected there and come down to simulation, and we'll say collider body. So we've got a collider body tag on our surround, and we'll copy this down and put it onto our base. So those two are completely set up. Don't need to touch anything. I mean, they can just be left there. They're static meshes. Well, we can say none in there. That's fine, and just leave that as off. And the same thing in here, just none and off. We can do that. Well, I mean, alternatively, you can just leave it as it is, but might as well do that. Secondly, we can set up our dice. So if I select both of those, tag simulation tags, and I just say rigid body, and we'll set them up accordingly. Let's see what we've got here. That's odd. I lost a tag there. Let's just copy that one down. Put it back on there. So let's see where we are in here. We might as well do both tags at the same time. So in our dynamics, we just simply need to say we want a convex hull as the shape. And again, we can say none and off for the inherit tag and the individual elements there, because we don't need to worry about those. In our bounce, I think we'll give it 30%, and our friction 80%, and we'll leave the collision noise the way it is. We could also come back up to these, and I think with the bounce again we'll say 30, 80, and we'll leave it at that. Just make those the same. Moving on from here, in the collision we've got convex hull set up, so that's perfectly good, and we don't need to worry about much else, but we do need to say that we want a custom initial velocity. We are interested in putting some figures in here. Now we're going to do a bit more work with Python a little bit later in order to control all of this and use random numbers and stuff like that in there, but for now, just as an initial starting point, I'm going to put 670 in the Y there and 2960 in the Z, and leave that at that. In the angular velocities here, I'm going to put 60 degrees, 154 degrees, and minus 73 degrees. So that's the dynamics set up. Let's just run the timeline and see what we're getting. Yeah, okay, so that's giving us a starting point. That's fine. Good. So we just bring our timeline back to 0, and then we can do a little bit more in the Expresso editor. First thing I'm going to do is give my dice a global position Y. We've got to use global position, of course, because our dice are actually grouped here. And you'll see why a bit later. There is a reason for that. So we've got our global position Y in there for a start, and then I can also get a compare node and plumb my output from the dice into there. Now in the compare, I'm going to change the function to less than or equal to, and I'm going to say 101. The reason I'm saying 101 is because if we go into our side view, we know that our dice is 200 in height, but our coordinates are in the center of the dice, so they must be at 100 relative to the dice. Now if our dice is on the table's base here, if it's hit the table's base, then it must be 100 at its center point must be 100 above 0, because the base is at the 0 point along the world axis there. So that's what we're looking for. We're looking for this to being less than 100. That way we know that our dice is grounded. And then obviously we need to know which face is facing upward. So once we've got the face and we know that our dice is grounded, then we can say that we need to actually analyze and freeze the actual score that's being generated by the dice at that particular point. If we didn't bother to look at this, even though the dice is moving and spinning and all the rest of it, there will be times when the face is actually pointing directly up in the Y. And if that was plumbed into the score, you'd find that the score would flash. It would flash numbers up every so often, and we don't want that. We only want the score to be there once the dice is grounded and come to a standstill and we know which face is pointing upwards. When we've got all of that data in there, that's the point at which we want our score to be generated. So that's why that compare is being put in there. Okay, so let's move on, and we'll get a time node, because we're going to do a bit more Python work and we need the time node for that. And as per usual, what I'm going to do in this time node, I'm going to take away the time port and add a frame port. And that gets that there. And then I'm also going to add another Python node. And once again, I'm going to strip this of all of its ports, just take them all away. And then I'm going to continue from here. As before, all the ports I'm going to need to add will be integers. So I'm going to add 1 here. In fact, I'll do 3 on the input stage. And I'm going to do 1 at the output stage. And then I'm going to rename them. This particular port we'll be calling bool check. The names will become apparent as we move on. You'll understand why I'm calling them what I'm calling them. Frame is going to be the next, and that's pretty obvious because we're going to plumb the time node in. We'll do that right now, actually. Plumb that into there. And input 3 is going to be score check. So score underscore check. And the output stage is simply going to be called score. And that completes that little part of it. Now the bool check we're going to take from the compare for the time being. It will change a little bit later, but for the time being we're just going to use this compare, because obviously when it's 0 it's not going to be correct, or it will be false, and it will be true once we get to the stage where we are less than or equal to 101. So we're going to get a bool value at the output, and that's fine, so we can use that for the check. The score check is simply going to be this number that's coming out of the Python node. And that will go in there. Right, let's go into the editor and start work. We'll get this sorted out. We start with the global score, and that's fine. Once again, we can take this away. We're also going to create another global variable called frozen. We can then say if frame is equal to 0, frozen is equal to an empty list, just open close brackets. We can then say if bool check is equal to 1, if score check is greater than 0, and len frozen is less than 1, frozen, dot append, score check. We can also then say if len frozen is greater than 0, score is equal to frozen bracket 0, else score is equal to 0. So what are we saying here? When our frames are at 0, or when our timeline is back at the beginning of the animation, we want to clear out the frozen list because we don't want our score frozen at that point, and we can just discard it. If we check our bool, so if our cube is, or our dice is less than 101 in the position Y, and the length of frozen is less than 1, so if there's nothing in here, then we want to append our frozen list with our score check. So whatever's coming out of here, that's the point at which we want to grab the score, because we know that the dice will be in its final position, and we know that we'll be able to get the polygon that's facing upwards and giving us our score. And then we can append frozen with that number. And then we can simply say that if frozen has actually got a value in it, we can output that value at the score port here. And if there's no value in our frozen list, we simply output 0. That's all we're going to do there. That keeps that nice and tidy, and it makes the score display when we need it to be displayed and at no other time. To finish this off, what we need to do is grab this text, this extrude. This is the text for this extrude, because that's the score. So we can bring this in to the Expresso editor and plumb our score into Object Properties, Text Spline. And straight away we've got a bit of an error in this Python here, so let's just select that. I'll close this one down, have a quick look in here, see what we've got going on. Right, so nums, yeah, that's okay. Upside, now hang on a minute, 0.99 is that's a float value. Now upside, if I just check here in my port information, I've created an integer for the port. That's where the problem is. So what I'm going to do is delete that port and add that back as a float, rename it upside, plumb my output Y back into there, and then place this up there. That's right, it's a real value. So we went from vectors to reals, not from vectors to integers, so we must remember that. That was my fault there, I just made an error. Let's just see if that's corrected things. We'll move this out of the way, and we make sure we're back at 0, and then fire this and see what happens. Yeah, the Python's now seems to be okay. It's not yellow topped anymore. Let's see. Yep, there we go. We did roll a 1 with the right hand dice, and that's the only one that we've got wired up at the moment to the Expresso and to our Python. So that's working perfectly well. Yeah, excellent. Now that we have one dice working successfully, we need to wire up our second dice and get that working too. So let's bring the timeline back to 0 and start looking at how we might achieve this. Just make a bigger window. First thing to do, I mean, I might as well do it here. If I just copy this dice node down to here, and then I drag in dice 2, put it in there, that sets that up for us. The iteration is obviously going to drive everything because we're going to copy, well, in fact, we're going to copy these 3 nodes for a start. So let's get those copied, drag those down into there, and then the iteration can drive the polygon node, and I can also plug in my object port from my dice 2. Just move this down to there to tidy things up a little bit. And then again, the iteration can be dragged into the eye of the Python node there to drive that. And that gets that all sorted out. I also need another compare node, so I'll drag this one down here, copy and hold down my command key and drag that down to there to copy it. And I can plug in my global position Y into the top port there. Moving on from here, I need 2 more nodes, the first of which is going to be a bool. So I'll come down to bool and just select one of those. It can be left in the function as an AND because that's what we need it to be. And I'm going to plug in both of the outputs from my compare nodes there. And then finally plug the output of the bool into the bool check. And that finalizes that. Just going to move these over a little bit because I just need to bring in a math node. So I'll come down to calculate math, bring that in. It needs to be an add, so we don't need to change its function. We'll leave it as it is, and we just need to add the values coming out of our Python nodes here to give us the values of both upward facing polygons of our dice. And we can plug the output into the score check. Straight away we get an issue with the Python node. I'm not too worried about that. That's because we just need to run things and just get it sorted out. So let's just run this and make sure that we're okay. And we get a value of 7 because we did indeed roll a 6 on the left hand dice and a 1 on the right hand dice. So everything is working fine, and you can see that the Python node there has sorted itself out and there's no yellow top on it anymore. So fantastic, everything is working, and that's the first part of making this thing work. The second part that we're going to look at next is we're going to be working with the dynamics, and we're going to be feeding the initial velocities, both the angular and the positional velocities, some random numbers in order to make the dice work in different ways and land in different ways every time they're thrown. I'll also be adding some user data so that we can move the positions or the start positions of the dice along the x-axis. In fact, I'll set that user data up first. I'll select Expresso. I mean, you can create a separate null and call it controller if you wish to, but for what it is, I'll just select this Expresso tag here, or Expresso null here, and then come down to user data, add user data, and I'll call it start position. I'll make it a float because that's what it needs to be. The interface can be float slider. Its steps and units are real, and step is 1. Yeah, leave it at 1. It can be 0.1 if you wish. In fact, we'll put it at 0.1. We'll make it 0.1. Why not? Now the min and max, well, obviously I've done this before, so I know that I want my min and max to be minus 1600 and 1600. And I know that those values will work fine, so I'm just going to check the boxes for the slider min and the slider max. And then I'll just hit OK, and that's our user data complete. What we're going to be working with is this null here. So the first thing I'm going to do is give my dice number 1 an Expresso tag, and I'm going to drag my Expresso null into there, come down to user data, start position, and then I'm going to drag in my dice null and add coordinates position X, wire those two together. And let's just double check to make sure that everything is working okay. So if I start moving this now, my dice move, and you can see that minus 1600 is good, and if I go to 1600, that's equally good. We'll set that back to 0, and all is well there. And that's the first little bit of Expresso that we've done to get the next part of our setup working. Moving on from here, once again I'm going to get a time node, and as per usual remove the time port and add a frame port. I then need a Python node. I'm going to remove all the ports. Bring in an integer and call it frame, and plumb the frame from our time port into there. Not bothered about the yellow top at the moment because there's lots more to do. I've got to put some output ports in for a start. So let's start to add these, and these are all going to be real values. So we can add 5 floats. And we can rename them. First one will be Y, Z, H, P, and finally B. The next thing I'm going to do is drag in this dynamics body. And I'm going to start bringing in the initial linear velocity. I want the Y, and I also want the Z. So that gives us those two, which are going to be wired together there, obviously. To take things further than this, we need our angular velocities. So we need the H, the P, and the B. And we can leave that set up ready for when we've sorted everything out in the Python node, and then we can wire them up. So in our Python node, I'm just going to open the editor. What do we need to do? Well, for a start, we're going to be working with random numbers, so we can say import random. We can then say from C4D import utils. And the reason for that is because I'm going to be working with the radian function or the rad function, so we need to import utils from C4D for that reason. Moving on from here, we can once again take away this line, and we're going to set some more global values. So, or global variables, I should say. So we can say global Z, global H, P, and B. We can also say global, oops, if we spell it correctly, global, and it will be random underscore Y, and then we can copy that, paste it in there, Z, H, P, and B. So that initializes our global variables. We can then say if frame is equal to 0, and we can copy this, paste it in there, and say equals that. Equals that, and finally B is equal to an empty list. So at frame 0 we're setting up our lists and we're making sure they're empty and they've got nothing in them, as we've done before. Moving on from here, we can now, also at frame 0, because this is when we want to do this, is start generating random numbers and populating those lists. So we can say if len random y is less than 1, random is equal to random dot rand int 200 comma 600, and then we can say random y dot append brackets random. And then from here we can just copy and paste this code, but this time it's going to be random z. So we just replace the y's with z's, and also our numbers we're going to change as well. So we go from 200, we're going to go 2000, and 600 will become 3500. So they're going to be the initial random values, or the range of random values that we can use to actually drive these two. And don't worry about that yellow top. It will disappear when everything else is complete, but that for the moment is what we're going to be using to drive those two. Moving on from here, we can say if len random h is less than 1, random is equal to random dot rand int minus 180 to 180, and then we can say radians is equal to c4d dot utils dot rad brackets random, and then finally rand h dot append radians. And again, we can copy this code and paste it here and simply say random p and random p. The minus 180, 180 is going to stay the same. That won't change for either this or the next paste that we're going to do in here. And again, we can change this to random b and random b. And that's as much as we need to do for the actual code that's going to be driving everything. And then finally, we can simply say y is equal to random underscore y, and once again we can copy and simply say z is equal to random z, h is equal to random h, p and p, and finally b and b. And we can then, I've missed a little bit off, you just say this, just put the, no, I don't want to see you, go away. We can just put zeros between brackets after each of them. And that completes it. That's the code that's going to drive our random numbers and make our dice behave in different ways every time they're thrown. So if we just wire these up, Hopefully we're right. I mean, if we're not, we can always do a double check and make sure I haven't done anything wrong, but it should be right. It should be perfectly good. The next thing to do is to actually copy. I'm going to bring this over here, but I'm going to copy it onto my dice 2. And I'm going to remove, because we only need it once. I just don't need this part, so we can remove that. Just take that away from there. And also, I'm going to drag in this dynamics body into here, so that we've got each dynamics body with its own Python code. Now let's see if this is right. I mean, if it's wrong, it's probably just a typing error on my part, but let's just see if anything happens. Well, it doesn't appear to be, so there's something not quite right there, because those dice would have both behaved in different ways. Let's have a quick look. Just go into the extensions and get the console and see if there's anything wrong. Let's have a look. Let's just, if I can, just go into here, bring this up and just execute this code. Right, okay, let's have a look. So it's a spelling mistake. So line 28, let's have a look. Ah, yes, I see, of course. It should be double P, not double A. That's all the way down because I copied. Let's just make sure that we get that right down there. That's okay, the other 3 are okay. I think we should be all right. Let's just go back to, yeah, it's I can see that we are all right because that's already gone away from there. So let's have a look and see what we've got. I think the only thing is, though, I've probably still got a problem in the other one here. If I just go into there, have I got a problem still in that code? Let's have a quick look. Open Python editor. No, that one's okay. It might be the other one then that I was looking at. Let's go into that one. Yeah, the other one's still got a problem. Okay, so let's go into there and correct that. It'll be the same problem, will it? Not sure. Let's just go into there and just reopen this to make sure that we're in the right place. Yeah, it is. It's the same problem. So if I just go to there and execute, yeah, we're okay. So I can close that down now and just close this down also. Now let's see what we get. Let's just run this. And now you can see the dice are both behaving in different ways. Yeah, that's fine. Make sure the score's okay. And we get 6. Perfectly good. So if we stop that, now what we can do, if we wish to, let's just get a hold of the Expresso here. Let's just move the start position, perhaps bring it over here and just see what happens then. Yep, and everything's still working fine. Let's see what we get. 4. 4 indeed. Yep, perfectly good. Let's one more go just to make sure everything's behaving as we expect it to behave. And we've thrown 7. Okay, so that's great. That's excellent. The dice are telling us exactly what we need them to. They're behaving precisely in the way that we want them to behave. Fantastic. Let's just have a look at that again so you can see what we've done there. And we'll also bring up a separate window to show you the other code as well, just so that we can have a quick look at everything that we've done, including our Python code. But as you can see, it was I suppose it is quite involved to actually get that to work, but it's not too bad as long as you sort of work systematically and do it in stages. I mean, quite a lot of it is just copy and paste, as you saw with the code, and also some of the nodes in the Expresso here. You can just literally copy and paste, and then it's just adding a few more nodes to make everything work with 2 dice as opposed to just a single dice. But yeah, that's all there is to it. That's the way you go about creating dice that actually work. And it was also important to introduce the polygon node, which was something, as I said, I'd never used before. And there are many applications for this. I mean, dice is only one of them, and I'm sure that you will be able to find a number of different applications for this particular node in your own work. See what you can come up with. But yes, that about wraps it up. That's as much as you need to do to make yourself a pair of working dice. All that really remains to be said is that I hope you've enjoyed this tutorial once again and that you've got something out of it. And if you have, then please give it a thumbs up. And if you haven't already, please subscribe to the channel, please leave a comment, and finally, please share. All those good things help to keep the channel going in the right direction. Anyway, that's about it for now, so I look forward to seeing you very shortly on the next tutorial.